Hi, good morning. So, as I was very well introduced, my name is André Medeiros, or as the, just check if this is working, as the conference people put it, André Medeiros, and that's okay, because a lot of my close friends can't even spell my name right when it's there. Anyway, today we're going to talk about building C extensions in Ruby. And the first question you got to ask is why. And basically, whenever I try to approach this subject, I like to draw a parallel with a bit of aviation because it's a bit of a passion of mine. And the reason why we got into aviation was because we wanted to get from point A to point B faster. But as software development goes, and the process of aviation went as well, we couldn't quite get it right the first time. So it's a bit of an iterative process and experimenting and so on until you get there. I'll just let the video finish. This is kind of like Ben's mail server earlier. So the point with this whole thing is that there's a lot of iteration. Things sometimes we build don't scale. And you know, in the end, you kind of get there. And one of the key points I want to make is Ruby is not a slow language. There's a lot of people saying otherwise. But it is not slow considering everything that we get for free. However, it's not always great for heavy processing. So if you're talking about a lot of work on statistics or parsing or processing images or video, obviously Ruby is not the first language you're going to go for. But this is one of the reasons why C extensions were built or were basically allowed into Ruby. And the whole point of it is that it's not hard to do. In fact, we ran a workshop on Wednesday, and the feedback I got from one of the participants was that they felt cheated because it was just really simple to get started on a C extension. And the other really cool thing is that Ruby's C API does feel a lot like Ruby. We all have a notion that C is a very hard language. Technically, it might be a little bit more difficult if you're coming from a Ruby beginning, but Ruby C API gives you a lot of that for free. And if you don't know C, there's a very good guide. You don't need the whole thing. Just the first 5 or 6 chapters will get you up to the point where you would feel comfortable building your first C extension. And whenever you're building a C extension as well, there's a couple of ways to approach the problem, depending on what it is that you're building. The first one is with whenever you're building an extension, you can go with C types as first-class citizens, and this is great for gems that involve back and forth communication. We use a lot of them. One of them, for example, is Nokogiri. Even if you don't have it in your gem file, there's probably a gem that uses it anyway. And this means that there's always a Ruby object in memory that holds like a reference to a C object behind it. And there's another method as well, which is where Ruby comes first. And this is better when it's a one-sided communication like MySQL too. So you're just sending queries to a database and you get results back kind of thing. And getting started is really simple. So most of you have probably done this already. This is the way you start off any gem these days with bundle gem. because what we do with C extensions involves a bit more than your standard gems, we need to add a few extra rake tasks. So the rake compiler gem includes all the clean and compile tasks that you need to get your gem built and running. And these are just a few lines that you have to add, so that's simple enough. You create an Ext folder, which is where your C code lives. This will be created at the root of your gem folder. And you finally create your extension configuration file. And what this does is basically, if you know C, the rake file came from makefile, which is the standard way of building C projects. And the makefile format is just atrocious. So, did I hear an amen somewhere? Yeah. Okay, there you go. So what Ruby does is we have a small library that's part of the core Ruby package called mkmf, which through a few methods will create a make file for you that you don't have to worry about maintaining or even losing your mind over. So this is a very, very standard and basic extconf. If you look at other gems, you might be looking at 400, 500 lines of code, depending on what you try to do. But this is basically your first couple steps. The next step is we go and start on boilerplate. So every gem that has a C extension needs to be initialized by Ruby. And this happens because we might need to define modules or classes or methods. Otherwise, it's pretty useless. So you go on to creating your first C file, where you include the Ruby headers. So that gives you access to the whole of Ruby's C API. And you define value SpeedyGem class or module or however it is that you want to do it as a global. And it's OK to make it a global. And finally, you have your init RubyConf, which is like your entry point for your gem. RubyConf should be whatever it is that your gem is called. And this is basically how defining a class looks like. So it's not as simple as Ruby, but it's not rocket science either. And with this, you already have a class that you can use up in Ruby, although it's pretty useless and does nothing. The next thing you need to worry about as well is memory management. Although this isn't exactly the complexity that you would have to worry about in an actual C program, all you have to tell Ruby is, well, here's how you allocate the memory, and here's a function where you free it. So Ruby will keep hold of the life cycle of your allocated memory, and it'll tell you when it doesn't need it anymore, which is perfect, because this is kind of where the biggest problems come with memory leaks. Obviously, to do work within your methods, you also need to retrieve your C variables, and that's also very simple. This is all standard Ruby C API, by the way. Data-get-struct will extract your C type from a Ruby object and give it to you as what you've defined earlier, so that you can do work on it. And from here on in, you just have to start creating your own methods. So this one's a very basic, say hi method, where it accepts one parameter, and that one parameter is a name. You'll notice that we always pass self as well, because C is a functional language, not an object-oriented language. Self is always the first parameter. And this is basically how a method would be defined. And if you call say hi on an instance of SpeedyGem, it'll say hello, comma, whatever name you pass as a string. Obviously, there's stuff that you need to do, like checking types. This is pretty simple as well. You can enforce types, Ruby types, with the checktype command. So here's a few examples of floats, fixed nums, strings, and hashes. Any base Ruby type that you'll have a type for it that you can just use with this function. If you want to enforce your own classes, it's a bit more involved, but again, not as hard as you would think it is. And here you can make it more flexible. So if you want to say, well, I expect a float or a string, then this is the way you would do it. As for method parameters, it's also as flexible as Ruby is. So you can obviously do parameters with methods with a fixed number of parameters, and this is the previous example of where I wanna make sure that one parameter is passed and that parameter is a name. With optional parameters, there's a little bit more code, and the function signature is slightly different. So we get accounts of the parameters that were passed and their values, and then Ruby has a nice method that checks, that basically extracts those parameters from what was passed. You can test if they're nils or not, or test for truthiness, and assign default values if you want, and finally the rest basically works as intended. As for the other parts of Ruby's C API, it does give you a lot. I'm just going to run through a few basic scenarios. First off, we'll start with strings. That first line right there would at least be 3 lines in C, for example. So this is how you create a string. Appending strings to each other is pretty easy. This is all stuff you can return to Ruby as well, so Ruby will see these as strings. As for arrays, it also has a really, really nice API. And the good thing is you can push whatever you want to a Ruby array. It doesn't have to be always the same type, pretty much as you would do in Ruby land. Hashes are also pretty simple. The only thing here is creating a symbol is actually harder than creating a string. So kind of want to, sometimes you might fall into the habit of creating strings instead of symbols, but that's a better example. And you can even do work with blocks. So even if you're building a C extension, let's say for a GUI front end, you could provide ways for me to say, here's a callback for when the user presses the mouse or taps down a key, for example, and you can save that block as an instance variable, or you can save it somewhere that you can call it later, kind of thing. So basically anything that you have access to in Ruby, you'll have access to in your C extensions to build with. And finally, the symbols. This is pretty much the only thing you need to know. This is how you create a symbol. And there's a bunch more stuff that you can do with it. This was just obviously a brief introduction. I've put up on GitHub a cheat sheet of the whole of a lot of the Ruby C API. It's a work in progress as well, so I'll be adding more. Keep an eye on it if you're interested. And the last thing I want to talk about is good practices. So whenever you're building a C extension, there's a few things that you have to keep in mind. First one being, define what your API looks like first, because there's a whole trove of C libraries out there that you might want to port, or even just create your own thing without binding any C libraries. It's nice to know how it should feel first before you start actually diving into code. So just run some Ruby code that doesn't even work and give it a try, see how it feels, and go from there. The second thing I recommend as well is returning self as much as possible. And this is because it allows you to chain operations much easier than much easier than if you had to do, like for example, on image processing, we worked on a very small image processing library where you could do image.blur.charcoal.save kind of thing, and that would all work. It kind of feels like, let's say, Rails is a query DSL. The third guideline is provide bang methods as much as possible. Chances are, if you're building a C extension, you're probably dealing with a lot of data. And in Ruby, if it's not a bang method, I'm assuming that you're just returning a copy of the object instead of the actual modified object. So if you provide bang methods, I know that whenever I call them, I'm modifying the objects. I'm not adding extra memory onto the running application. So just provide those as well and change it in place instead of duplicating. And finally, Ruby doesn't always map one-to-one to C libraries, and this means that we have our own way of writing code and naming things and so on. So it's okay if you get stuff lost in translation. And by this, I mean, I ported OpenCV to Ruby, and one of the things that really ticked me off was that an image was called a matrix in OpenCV, and that's just way too academic for me, so I just called an image, and that's fine, because the reason why I ported it into Ruby was because I didn't want to worry about the C side of it. So if don't worry about getting lost in translation and naming things differently, because it'll be fine. And that's it for today. Any questions? Yes.
There was a big push to...
Hang on, Clifford. Even Clifford needs the mic.
There was a big push to use the foreign function API.
The what, sorry?
The foreign function interface, FFI, rather than using C extensions. How do you choose?
Well, I tend to go with C extensions like purely because it's one last layer that you have to worry about. So it's more of a matter of directness and control. So you know exactly what's going on. You're not at the mercy of bugs of even another library that you're introducing in the middle. I mean, this is basically as down to the metal as you can go, kind of thing. So you have control of everything that's going on, and if there's something wrong, you know it's you, and not FFI or anything else. No.
Could you go back to the GitHub link?
Yeah. So I'll put these slides up anyway. But yeah. Sorry.
All right. Thanks.
Questions? Yep.
How do you debug this? Can you use like regular debuggers like GDB?
You can attach GDB to a running Ruby process, yeah. One of the good things that you can do as well is provide a console rig task that will just run your gem with a bunch of fixtures. And if you attach GDB to the PID of the running Ruby process and trigger an exception or a Stack Overflow, whatever it is, then you can backtrace on that and see exactly where the problem lives. If you just want to go on a simplistic approach, you can just printf stuff. But GDB also works pretty well.
Okay, there's two things that I've had experience with the C extensions that I think are give them a really good use case, and one is a concurrency, being able to do things outside of the Ruby GVL, and the other was basically gotchas to do with garbage collection. I was wondering if you had any advice in those regards?
Well, let me just go back a few slides actually, just to show something. The memory management. Yeah, here we go. So, in terms of garbage collection, you've got two options that you can use: one, the other, or both. Here I'm passing null, and this is a method that you can specify for the Ruby mark, right? So whenever Ruby marks an object to be garbage collected later, you can know in advance that that's going to happen. Free will just say, okay, I've gotten rid of the Ruby objects and feed it all together. Depending on what you're doing, and I find that in 99.99% of the cases you don't need it. If you're sharing big value or big big chunks of memory across different variables, you tend to use the mark. So you do a bit of reference counting there, and you say, okay, if this is going to be marked for garbage collection, then I'll subtract the counter. If I assign this to another Ruby object, I increment the reference counter kind of thing. But in most cases, you don't need to do it. So in terms of gotchas, I haven't run into any, even just going with this simple approach.
Have you ever deadlocked the GVL using mutexes in C?
Yes. But that was because of the threads, not the...
Just the ones.
So I've noticed like Ruby's really good about publishing a changelog between versions, and they're really bad about publishing a changelog for the C API between versions. Do you know if like either does it just not change that much, or is there like a different place that we should look for whatever, like what actually changes under the hood, what new C, like C calls, like what's deprecated? Like it's just really hard to find like the documentation for the underlying C of Ruby.
You're absolutely right. They don't publish the C API changelog with the rest. But what I do find is that, and I've been doing this kind of stuff since Ruby 1.9.3, things haven't really changed that much. And one of the things I've done was fix Ruby deep clone, because at my previous company we were marshalling and non-marshalling stuff just to clone them. And that was several megabytes of data in memory that took just forever. So that was like the lowest of lowest that I had to go to kind of to optimize performance. And the only thing I had to worry about there wasn't even Ruby at all. It was about the Falcon patch that had slightly different internals. Apart from that, every single C gem that I've written compiles from Ruby 1.9.3 to 2.1.0 without any single problems.
I have a question. Mm-hmm. The OpenCV, the idea with that is that it's low level and super high performant to get real-time visuals. Mm-hmm. What's it like running it inside of Ruby?
Exactly the same. I mean, the only overhead you're getting there is creating a Ruby object around OpenCV. Any other instructions that run don't touch Ruby code. They go directly down to the metal kind of thing. So. And the reason why we did it as well was because I basically spent 3 months working on C++ code, and I missed Ruby so much that I just took a weekend off, wrote the bridge, and went back to Ruby, and was a very happy man.
Cool. Let's thank André.
Thank you very much.